Well, the research goals are actually, we have in the astronomical community, every 10 years we review what science has been done, what the exciting science was, and what we believe the next set of science objectives will be the most interesting, and it's called a decadal survey. So that was published in 2010. So we do tend to sort of align our research goals with what the whole community decides is the most exciting stuff. So the sorts of things that are most interesting, that are accessible to a ground-based optical and infrared telescope. I mean, there's some things that you can only do from outer space if it's X-rays, gamma rays, or ultraviolet. We focus on those science objectives that are accessible in the visible, the wavelengths you see with your eyes, and also the near infrared. And so the sort of the big things are how structures start formed in the universe. There's a phase, the earliest phases of the universe, all of the hydrogen in the universe was neutral, and so it's essentially opaque to most accessible wavelengths. And then all of a sudden, within this soup that we call it the Dark Ages, the furniture of the universe starts to evolve. The first giant stars, proto-galaxies, and then as they form, they make a lot of ultraviolet radiation because they get very, very hot, and they actually then reionize the universe. They take all of the universe at this point consists almost entirely of hydrogen. And so what it does is it takes the hydrogen atom, which consists of a proton and electron, and rips them apart. And in this new state, this ionized phase, the stuff between the galaxies and the stars becomes visible, transparent again. And now we can see what's going on. So something like 200 million years into the age of the universe, this dense opaque soup turns into porous Swiss cheesy stuff and eventually becomes entirely transparent. And that's, in our universe today, all of the stuff between the galaxies is ionized, so that's why we see the Andromeda galaxy and all those special, well, all the things outside our own galaxy. So what we want to do is understand what's going on when the shape of the universe starts to actually assemble it. The stuff of the universe starts to assemble itself into the shapes we see today, and then to track that history from the earliest phases to the present phases. We also study that a different way. It turns out that the stars that were made out, the earliest stars that were made up entirely out of hydrogen, probably were very massive stars and blew up. But there are some fossil relics of those stars that still exist today. And so we call these metal-poor stars because they consist entirely of hydrogen, a soupçon of helium, but essentially none of the other constituents of the periodic table. Astronomers see the universe as consisting of hydrogen, helium, and metals. So calcium is a metal, and aluminum is a metal, but everything else is a metal. So we look for extremely metal-poor stars, and these then are the fossil records of that formation. So we look way back in time at the time the Dark Ages are ending, and then we also actually look at the fossils that are still present today in our local universe, very close to our own sun. Another thing that we're very focused on, of course, is the search for Earth analogs, Earth twins, Earth 2.0, Earth-mass planets orbiting solar-type stars in the habitable zone, which is the zone where the planet is orbiting far enough away from the sun so water isn't steam, everything isn't getting cooked, but also close enough so water hasn't frozen. And so the sort of special distance away from the host star, some people call it the Goldilocks zone, where water is liquid, is hoped to be the place that life might start on other exosolar systems, other solar systems orbiting. Solar systems are the sun. Systems orbiting stars other than the sun, exosolar systems. You know, we're a pretty narcissistic species, so it's always possible that there are entirely other ways to make life. Instead of living in water, I guess things could live in mercury or methane or something else, but we probably believe that, well, it's the principle of the lamppost. You don't look for your keys where you think you lost them. You look for your keys where there's light. And so this is, we have existence of one planet that's mostly, the surface is covered with water, being the birthplace of life, so it makes sense to look other places.
Okay.